Okay, the stopping distance of a car varies directly as the square of the speed of the car. So d is equal to k times s squared, where d is the stopping distance and s is the square of the speed of the car. If a car traveling 50 miles per hour has a stopping distance of 170 feet, so let's plug in the 170 as a distance, so 170 goes in for d, k times s, which is 50 miles per hour, squared. So I can use this to solve for k. So if I do 170 divided by 50 squared, I get k equals 0.68. And so then I can get d is equal to 0.68 s squared. So this is my model. And now I want to find the stopping distance of a car that is traveling 70 miles per hour. So d equals 0.68 times 70 squared. 0.068 times 70 squared, I get 333.2. So 333.2, and again, this was a stopping distance, which is measured in feet. Given a function, find each of the following. Use complete the square to write the function in vertex form. Okay, so if I take this f of x, so I have 2x squared minus 4x minus 3. The first thing I can notice is the first two terms have a factor of 2 there. So I'll have x squared minus 2x. And what I want to do is I want to add. So if I do negative 2 over 2 and then square that, that's going to be negative 1 squared, which is plus 1. And when I added this 1 here, I didn't really add just a 1. I added a 1 times 2. So I need to subtract that 2 off of there. And so what I end up with is 2 times x minus 1 quantity squared minus 5. So that's the vertex form. State if the parabola opens up or down. So I notice that the first thing here is positive. So it opens up. Identify the vertex. The vertex will be, this is my HK. So my vertex is at 1 comma negative 5. And then state if the function has a maximum or minimum and give that value. So since it opens up, it has a minimum. And the value is negative 5. Because that's the y coordinate. State the domain and range. So the domain is going to be all real numbers for any parabola. And the range, well, let's just think about the graph of this. So 1, negative 5 is the vertex, and it's opening up from there. So the y values that it hits are going to go from negative 5 included to infinity. A professional skateboarder launches into the air at an initial velocity of 5.4 meters per second. His path, his center of mass can be modeled by that. Determine the time at which he reaches his maximum height. Okay, so I was just going to do this on my calculator here. So negative 4.9 squared plus 4.9x squared plus 5.4x plus 3. Oops. Okay, we'll graph that. Okay, and so I want to do the time at which he reaches his maximum height. So I'll just calculate that maximum. And it looks to me like the graph looks something like this. And that maximum happens at 0.55 seconds. And the height is 4.48. so the time is t is equal to 0.55, and then, so that's to 2 decimal places. Then the maximum height needs to be the nearest tenth of a meter, so it's going to be 4.5 meters. Okay. Find the vertex of that function using the vertex formula. Okay, so for this, I'm going to have, I'll note that I can pull a 4 out of the first two terms. Okay, and then what do I want to add here? Well, I'm going to do this -6 divided by 2, which is -3, and then square that. So I'm going to do +9. But I didn't really just add a +9, I added a 9 times 4, so I need to subtract off 36, which is 9 times 4. So then I get 4x minus 3 squared minus, -36 plus 11 is -25. Okay, and so the vertex is at 3, -25. The braking distance required for a car to stop depends on numerous variables, such as the speed of the car and so on. Use regression to find a quadratic function to model the data. All right, so I hit stat on my calculator, enter in all those things, and then I can do stat calculate, and I can go down to quadratic regression, and I got, let's see, round to 3 decimal places. So I'm going to get D equals 0.039 S squared plus 2.532S minus 2.509. Okay, so that's my 3 decimal places on that quadratic regression. Okay, use the leading term test to determine the end behavior of that polynomial. Okay, so the first thing I want to note is if I look at this leading term, that the highest power is odd. So the degree is odd, and the leading coefficient is positive. So that means it's going to have the same end behavior as like x cubed. So it'll go up like this and down like that. So I'm not sure how you indicate that, but anyway, as x goes to positive infinity, this thing is approaching positive infinity, and as x goes to negative infinity, this function will approach negative infinity. Okay, find the zeros and multiplicities of each of each. Okay, so this term is telling me that one of my zeros is x equals 4, multiplicity 2. And then this term is telling me x equals -3, multiplicity 3. This one is x equals -5, multiplicity 1. And then this is x equals -2, multiplicity 4. Use long division to find the quotient and remainder. Okay, so we can do long division here. So we have 12x to the 4th minus 4x cubed plus 13x squared plus 2x plus 1. And note that I have 4th degree, 3rd, 2nd, 1st, 0. Okay, if we had any terms left out, we'd need to leave a space for them, but we don't have anything like that. So then I have 3x squared minus x plus 4. Okay, so the first thing I want to do is I want to look at this 12x to the 4th, and I want to say, okay, what do I need to multiply this by, 3x squared, to get 12x to the 4th? So it's going to be 4x squared. Then I'm going to multiply the 4x squared by each of these guys, 1, 2, 3, and so I can do that. So I'm going to get 4x squared times 3x squared is 12x to the 4th minus 4x cubed. 4x squared times 4 is going to be plus 16x squared. Then I want to subtract all of that. So 12x to the fourth minus 12x to the fourth will be 0x to the fourth. 4x cubed, negative 4x cubed plus 4x cubed is 0x cubed. And then 13x squared minus 16x squared is negative 3x squared. And then I'll just go ahead and drop this down. Plus 2x plus 1. Okay, so now I'm going to look at this term here and see what do I need to multiply negative 3x squared by to get, 3x squared by to get negative 3x squared. And the answer is just negative 1, of course. So minus 1. And then we'll multiply this minus 1 by each of those things. So we'll get negative 1 times 3x squared is negative 3x squared. Negative 1 times negative x is plus x. Negative 1 times 4 is going to be minus 4. Then I want to subtract all of that. So that gives me 0 in the x squared. 2x minus x is just x. 1 minus negative 4 is going to be 1 plus 4, so it's 5. So then this is my remainder. Okay, and if I wanted to write this out, I could write this as 12x to the fourth minus 4x cubed plus 13x squared plus 2x plus 1 divided by 3x squared minus x plus 4 is going to be equal to 4x squared minus 1 plus that remainder, x plus 5, divided by my divisor, which is 3x squared minus x plus 4. So that's the way we would write it all out, okay, if we were writing it. So this is the quotient, and that's the remainder. Okay, then it says use synthetic division to find the quotient and remainder. So since I'm dividing by a linear term here, I can use synthetic division. So we've got 2, 13, negative 3, negative 58, negative 20, positive 24. And the 0 here is 2. Okay, so we're going to drop down this 2. 2 times 2 is 4. 13 plus 4 is 17. 2 times 17 is 34. 34 minus 3 is 31. 31 times 2 is 62. Minus 58 is 4. 4 times 2 is 8 again. Negative 20 plus 8 is negative 12. 2 times negative 12 is negative 24. So actually my remainder is 0. So the quotient is, so that's for this one, right? The quotient is going to be given by these coefficients. So the quotient is going to be, let's see, the negative 12 is a constant, the 4 is times x, 31 times x squared, 17 times x cubed, and 2 times x to the fourth. So we'll have 2x to the fourth plus 17x cubed plus 31x squared plus 4x minus 12. And the remainder is 0. Now find all the zeros of the polynomial function, given that 2 and negative 5 are some of the zeros of the function. Okay, so what I can do is I can use, again, synthetic division to divide out the ones that I have here, that I'm given, and then what's going to be left is a quadratic, so I can go on from there. Okay, so let's see if we can do it. So we're working now on number 51. So let's go ahead and put this here in synthetic division. So 1, 3, negative 13, negative 9, and 30. And again, since I have all of the degrees here, I don't have to leave any extra spaces. So I know that 2 is a 0. So let's go ahead and divide that out. So I have 1, 2, 5. 5 times 2 is 10. 10 plus negative 13 is negative 3. We'll get negative 6. Negative 9 minus 6 is negative 15. And negative 15 times 2 is negative 30. So again, we get the 0. And now I can divide that out again. I'm going to divide out the negative 5 is a 0. So we've got, drop the 1 down. 1 times negative 5 is negative 5. That's a 0. 0 here. Negative 3. Negative 5 times negative 3 is positive 15. Again, I get it 0 there. And so what's left over is x squared plus 0x minus 3. Then we'll have x plus 5. Then we'll have x minus 2. So those are the terms that go with the 2 and the negative 5 zeros. Okay. And so from this one, I can get the rest of the zeros. So if x squared minus 3 equals 0, it gives me x squared equal 3. So x is equal to plus or minus square root of 3. So the zeros are 2, negative 5, and plus or minus square root of 3. So that's 1, 2, 3, 4 zeros. Find a degree 4 polynomial in standard form with rational coefficients given that I, negative 2, and 4 are some of the zeros of the polynomial. Okay, so if I know that I is a 0, and I know that it has rational coefficients, I know that negative I is also a 0. So I can write it all out. So I have x minus I, x plus I, x plus 2, and x minus 4. So that one should work. Now, it says find a degree 4 polynomial. So I could have a different coefficient here, but it just says to find one of them, so I can find whichever one I want. So I'm just going to find the one that has the coefficient of 1 here in front. But if it gave you some other thing that, some other piece of information, we might have to find a number that goes in front there. But I think we're good here. So if I multiply this all out, I'm going to get x squared plus 1. If I multiply x plus I times x minus I, times x plus 2 times x minus 4. And so I'll get x squared plus 1, then if I multiply that out, I'll get x squared minus 4x plus 2x, so minus 2x, and then 2 times negative 4 is minus 8. And then I can multiply this x squared times everything, and the 1 times everything, and we'll see what I get. X to the 4th, minus 2x cubed minus 8x squared plus x squared minus 2x, minus 8. So that gives me x to the 4th minus 2x cubed minus 7x squared minus 2x minus 8. So this is a polynomial that is a 4th degree polynomial that has the zeros I, negative 2, and 4. Then it says find all the possible rational zeros of that polynomial function. And so what I want to do is I want to take my p's are going to be roots of, or factors of this 8. So plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And my q's are going to be rational or divisors of 2, so plus or minus 1 and plus or minus 2. So if we want to do all the rational roots, we want to do the p's over q's. So if I do p over q would be plus or minus 1 over 1, plus or minus 2, plus or minus 4, and plus or minus 8. And also 1/2, 2 halves, 4 halves, and 8 halves. So 1/2 is something different. 2 halves is just 1. We already have that. 4 halves is, we already have that. It's 2. And 8 halves, we already have that. It's 4. So these are all the possible rational roots. So that goes here. Given that rational function, find the vertical asymptotes. So what we want to do here is we want to see if anything's going to simplify from this guy. So let's go ahead and factor the numerator and denominator. So I have f of x is equal to x minus 2 over, let's see, this is going to be x, let's see, factors of 18. Let's see, you got 3 and 6. So I want the 6 to be negative and 3 to be positive. Yeah, that'll work. Okay, so the vertical asymptotes are going to be given by the denominator. So it's going to have vertical asymptotes. Since we don't have any common factors in the numerator and denominator, both of those factors in the denominator will give me a vertical asymptote. So I'll have a vertical asymptote at x equal negative 3 and a vertical asymptote at x equals 6. On number 55, I want to find the horizontal asymptote. And so the horizontal asymptote I can find by looking at the leading coefficients, or leading terms of both of those. And so I can see that I have an x cubed on top and bottom. So since I have the same degree on top and bottom, I'm just going to look at the coefficients of that. So my horizontal asymptote is going to be y equals 3 over 8. And then for the slant asymptote, I can notice that the degree on top is 1 greater than the degree on bottom. So that means I'll have a slant asymptote. So I'll have to find that by dividing. So we'll do long division, x cubed minus 3x squared minus x minus 3. And we want to divide out x squared minus 2x. So then I'll just need an x here. X times x squared is x cubed. X times negative 2x is negative 2x squared. I want to subtract all of that. So I'm going to get 0. Negative 3x squared plus 2x squared will be negative x squared minus x minus 3. Okay, so then I want to do negative 1. So negative 1 times x squared is negative x squared plus 2x. And then I'm going to subtract that. So I'm going to get 0. And I'm going to get negative x minus 2x, which is minus 3x minus 3. So we don't worry about the remainder, but the slant asymptote is going to be the quotient. So it's y equals x minus 1. So the remainder doesn't matter, but the slant asymptote comes from the quotient.